What's up, everyone? Welcome back. Patrick here. Moving on to the next example. Here we have to rationalize the denominator of this expression here. So we have the square root of x plus the square root of x plus 2 all over the square root of x minus the square root of x plus 2. So if we're going to rationalize the denominator here, notice that this is a two-term expression, right, in the denominator here, meaning that we're going to have to multiply it by its conjugate. We're going to have to multiply the denominator by its conjugate, so we would multiply it by the ends, and we would switch the sign in the middle. Not this sign here, right? Under this square root, the sign stays the same. It's only this sign in the middle that is changing. And we can't just randomly multiply the denominator by some expression, so we also have to multiply the numerator by that same expression, like that. Right? And so from here, we're basically multiplying this expression. This is like multiplying it by 1, right? This bracket's going to be 1, and we're just going to be changing the format for it. So in the numerator, I'm actually going to, let's just keep it. Notice that these are the same, actually. Square root of x plus the square root of x plus 2 multiplied. So I'll write the square root of x plus the square root of x plus 2 squared. Right, because there's two of them there. And then at the bottom, what's going to happen is we just have to multiply the ends by each other, right? Because this is like a difference of squares. It's like a minus b times a plus b, right? So a minus b times a plus b is just going to be a squared minus b squared, right? We just have to multiply the ends by each other. So square root of x times the square root of x gives us x minus the square root of x plus 2 times the square root of x plus 2 gives us x plus 2. You got to just make sure that that x plus 2 goes in brackets like that. And so from here, what can we do? You know what I'm going to do, actually? I'm going to take this expression, and I'm going to bring it to the side here. And I'm going to FOIL it out. So I'll have the square root of x plus the square root of x plus 2 times the square root of x plus the square root of x plus 2, just so there's not too much going on here in our main work. So let's FOIL this out. Square root of x times the square root of x is x. Square root of x times the square root of x plus 2, that's just going to be, let's just keep them separate like this for now. And then same thing here, square root of x times the square root of x plus 2. These are going to be like terms. So again, let's just keep those separate. And then the square root of x plus 2 times the square root of x plus 2. And notice the roots cancel out, and we're just left with x plus 2, like that. So collecting like terms, this and this x, these end up being 2x. And then the 2, let me just bring that in front as well, this 2 over here. And then notice that these are like terms, right? So we have the square root of x times the square root of x plus 2 plus the square root of x times the square root of x plus 2. There's like a 1 and a 1 here. So we can add those because they are like terms, like that. And another thing we can do is these two roots we could actually multiply, right? Because if you have, let's actually write it up here. If you have like the square root of m times the square root of n, you could actually multiply those two expressions under one root. So let's actually do that right there. And so we can multiply the x into the x plus 2. So two ways we could do it. We could either keep them separately, like that, or we could also distribute the x in that, inside that bracket. So we'll have x squared plus 2x, like that. So you could write as x times x plus 2 in brackets, or you could distribute the x and have x squared plus 2x. I'll probably just leave it like that. And so this is basically what this numerator is going to simplify to. So let's write that up there, 2x plus 2 plus 2 root x squared plus 2x. Okay, and then that's still going to be all over. Notice we can simplify the denominator here, distribute the negative inside the bracket. The x's would cancel out. X minus x is 0. And then negative 1 times 2, that would give us that negative 2 right there. And then at this point, what I'm going to do is I'm actually going to split this up into multiple fractions with this denominator of negative 2. So I'm going to take this 2x, I'm going to divide it by negative 2, 2 divided by negative 2, and then I'll have the 2 root x squared plus 2x and divided by negative 2. Because I was noticing that the 2's are basically going to cancel out. Another way you could think of it is you could factor out a 2 in the numerator and then cancel out with this negative 2 at the bottom. I just split it up like this, right? There's different ways to simplify this. So whichever way you're going to do it, just make sure you're getting the same answer. So 2x divided by negative 2, that gives us negative x. And then we'll have 2 divided by negative 2, which is minus 1. And then this 2 divided by negative 2 is also a minus 1. So there's like an imaginary minus 1 in front of the square root there, which we don't have to write. We could just write minus the square root of x squared plus 2x. And so from here, I feel like you can't simplify this any further, right? So not only did we rationalize the denominator because we only had an integer left, no roots, that's what it means. There's not going to be any roots left in the denominator. There was also opportunities to simplify it further. And that's a wrap for the video. Hopefully you enjoyed that. If you want to see more videos like this, please go to my website, allthingsmathematics.com. Over there, all of the videos are organized by chapter, by section. If you feel like you need tutoring at any point, you could also hit me up. My contact details are on the website. Enjoy your day, and I'll see you in the next one. Peace out.